Well, this video is for Math 111 for sample test number 2, and as we did with test number 1, your test will be very similar to this. You'll have the same number of questions, the same kinds of questions, but different questions. So let's go ahead and get started. Problem 1, we've got, let's see, 2x to the third minus 5x squared minus 7x plus 2, and we want to know where is that going to be greater than 0. So what we need to do is find the roots for this equation and then look at where the graph is above the x-axis and where it's below the x-axis. So I'll sketch a little version of what I'm seeing on the calculator, and then I'll show it to the camera. Something like this. Okay. So we need to find what are these roots here, here, and here. Let me show you to the camera what I'm seeing on the calculator. So there's what's going on with the calculator. So what we're going to do is we're going to identify those roots, and then we can determine where is y going to be greater than 0. Now let's see if we can get rid of that glare on the board as well. Okay, good. All right, so where are these roots? Let's see, that first one here is going to be negative 1.181 is what that looks like. Okay. Negative 1.181. That second root looks like it's between 0 and 1. Yeah, 0.247. And then that last root over there looks like it's between 3 and 4. Yeah, 3.434. Okay. So we're looking for where are the y's greater than 0. Where is it above the x-axis? That's going to be here and also out here. So that's x less than 0.247 but greater than negative 1.181. Or out here, x is greater than 3.434. All right, there's problem 1. Let's go ahead and take a look at problem 2. So, here we've got 6x to the 4th minus x cubed minus 12x squared plus 3x plus 1. And this time we want to know where is it going to be less than 0. Where is the curve going to be below the x-axis? Let's see here. So again, I'll put a little sketch up on the board, and then I'll show what it looks like to the camera so we can get a sense of what we're working with here. Okay. So this is kind of coming down, going back up, and making kind of a big W like that. Oh, there's the calculator. And there's the graph that we're looking at. So we need to go in and find out what those roots are again, and then look at where is the graph going to be less than 0 down here. So there's the roots. The answer to our question is going to be here and here, right? That's where it's negative. But we need to know what those endpoints are to answer that question effectively. So that far left one, negative 1.425. Let's see here. The next one, negative 0.192. positive 0.462. And then that last one, uh, 1.322. Okay, so we already identified our intervals there where the graph is going to be below the x-axis. So now we just have to represent these two intervals with two separate statements. X less than negative 0.192 but greater than 1.425, or x less than 1.322 but greater than 0.462. So there's problem 2. Where is the graph less than 0? All right, let's take a look at problem 3. Okay, on 3, we've got 5x squared plus 5x minus 9 on top, 3x squared minus 2x minus 7 on the bottom, and we want to know where is this going to be greater than 0. So again, I'll put a little sketch up here, and then I'll show the calculator to the camera so we can see just what we're working with. Okay, so we've got an asymptote over here somewhere. The graph kind of does that. And then we've got another asymptote over here. The graph kind of doing that. And then like this. So that's kind of what we're looking at. Let me show the camera. Let's see what I'm sketching from. So there it is. And again, we need to go in, find those roots, and find the asymptotes as well. Okay, so you can use the root finder on the calculator to find those roots if you want to. You can also use the quadratic formula. Let's see here. I'll use the quadratic. Let's see here. 5, 5. Negative 9. So this is going to be x equals 0.931 and negative 1.930. Oh, these are 932. We've got to round up. Okay, and then the asymptotes, that's going to be where the denominator is 0. 3x squared minus 2x minus 7. This one we have to run through the quadratic. And this is going to give us x equal to 1.897 and negative 1.230. Okay? So let's identify those points on our graph. So here's one root at negative 1.932, and then the asymptote is here at negative 1.230. Then this root is 0.932, and then this asymptote over here is positive 1.897. Okay, so we've got all those critical values identified. We need to answer the question, where is the graph greater than 0? Where is it above the x-axis? So there's one region, here's another region, and here's another region out here. So we've got 3 different intervals where the graph is greater than 0. So we're going to need 3 separate statements. So one will say x less than negative 1.932, or x less than 0.932, but greater than negative 1.230, or this last one, x greater than 1.897. Okay, there's problem 3. And we've got another one of these rational inequalities to look at. Let's see, I'll leave those roots and asymptotes there. And we'll take a look at number 4. Okay, let's see here. So, number 4, what do we have? X squared minus 5x minus 7 on top. X squared plus x minus 5 on the bottom. And we want to know, where is this one going to be less than 0? So let's do a little sketch so we can have something to work with. And let's see, we've got an asymptote out here, and then part of the graph is doing that. We've got an asymptote over here, and that middle section is doing something like that. And then there's a piece over here that's doing that. So it looks like we've got a root here, a root here, and then 2 asymptotes. And sometimes it's hard to see this root over here, but when you solve it algebraically, it'll show you that there's a root out there. So that's why it's sometimes important to do the algebraic solving, because it can be hard to see on the graph itself. Okay, so the roots are going to be what make the numerator be 0. And let's see, that is going to be 6.140 or negative 1.140. There we are. And negative 1.140. And then the asymptotes, x squared plus x minus 5. That's going to be 1.791 or negative 2.791. So there's 1.791 and there's negative 2.791. And we want to know, where is the curve below the x-axis? Where is it negative? So we've got just these 2 regions here and here that satisfy that. Oh, and I think I didn't show this graph to the camera for problem 4. So let's go ahead and do that. So that's what it looks like. Okay. So let's go ahead and represent these intervals then. This is x less than 6.140, but greater than 1.791, or x less than negative 1.140, that's a negative sign, but greater than negative 2.791. Okay, so that's it for the inequalities. Over on page 2, we have 2 problems just like what we were talking about. Let's see here. Just like we were talking about in section 2.8. Okay, let's see. I'm looking at this answer key, and the answers for problem 4 are different than what I've got up here. I think I may have changed that problem. Let me run that denominator through the quadratic one more time. Yeah, I think that's what I did, is I changed that problem and neglected to change the answer key. So I'll have to fix that. Okay. All right. Let's look at problems 5 and 6, and I will take care of that answer key when I get a chance. Okay. Problem 5. We've got 5x cubed plus 9x squared minus 3x minus 18 equal to 0. So let's go ahead and graph this. And then we will take a look at where those roots are. Okay, so again, I'll draw a little sketch. Here the graph is not quite as important. We just need to know what is this root right here. That's the really important part. This is not really very exciting on the calculator. You just see that line with the root just greater than +1. And so we'll use the root finder on the calculator. Second trace number 2. Set a left bound and then set a right bound. And this is 1.2. And again, if you're not sure what that is as a fraction, then you can go back to the regular calculation screen and just type in, let me show you. So here's the graph. So if we hit second mode, which is quit, and then type in 1.2, go to the math key. Choice number 1 is make that a fraction, and there it is, 6/5. And that makes it a lot easier to find the factor of that polynomial. So, if x is 6/5, 5x equals 6, and the factor we're interested in is going to be 5x minus 6. And then we can do the synthetic division and find out what the other factor is. So, let's see here. 5, 9, minus 3, minus 18. We'll use our 6/5. So, 5 times 6/5 will be 6, and then 15, and then 15 again, and then 18 will give us a 0 remainder. Pull out this common factor. This will be x squared plus 3x plus 3. Right? That common factor of 5, factor it out, and we'll be left with x squared plus 3x plus 3. And we'll run this through the quadratic and get our complex valued solutions. So, negative 1.5 plus or minus 0.866i. There's our 2 complex solutions, 1 real solution. That makes 3 solutions, so we're all set. Okay, so let's take a look at problem 6. Problem 6, 4x to the 4th minus 9x cubed plus 19x squared minus 19x minus 30. All right, let's get this graphed here. And let's see. All right. 30. So what is that going to look like on our graph? I'm going to see a line coming down here, and then another one going up there. So let me show you what that looks like on the calculator. So there it is on the calculator. And it looks like there's a root at +2. And if you go into the table, then you can see, yeah, when x is 2, y is 0. So that's good that we know that one. And then we'll find out what the other one is in just a minute. So this root is +2. let's see what the other one is. Negative 0.75. Okay. So again, if you know that this is negative 3/4, that's helpful in making the factor. If not, you can use the calculator to tell you what that is as a fraction. So x equals negative 3/4. 4x is negative 3. And the factor we're interested in is going to be 4x plus 3. Then we've got an x equal to 2. So our other factor is x minus 2. And then we've got this missing irreducible, non-factorable quadratic factor right here. So let's go ahead and do our synthetic division. Let me make some room here. So 4 minus 9, 19 minus 19 minus 30. And again, it doesn't matter which one of these we use first. I'll start with the negative 3/4. So let's see, that should be negative 3, and then positive 9, and then let's see, negative 21, negative 40, positive 30, there we go. Okay? All right, one more time with the 2, the positive 2, 8, negative 4, negative 8, 20, positive 40, and there's our other zero remainder. We pull out the common factor, which is 4. This will be x squared minus x plus 5. And let's see what we get as roots for that one. Let's see, minus 1, 5. So this is 1/2 plus or minus 2.179i. 2 complex roots, 2 real roots. That makes 4 roots. And so there we go. All right, so that's it for test number 2. When we get done with this, we'll move on and start talking about chapter number 3. As always, if you have any questions about this, we can address them in class. But please do get them addressed one way or another. Thanks a lot.